on to topic 3 in your stoichiometry notes. So this is called percent yield, and it's on page 8. So percent yield is obviously going to be a percentage. If you recall, percentages are always calculated in a certain way. It's always the part of something divided by the whole thing times 100. So we are going to be talking about the percentage of what we should get versus what we actually got. So let's talk about what that means. So stoichiometry, here's a big idea. Stoichiometry calculation. It bases its answer on ideal reactions. It's based on ideal reactions. And many reactions, though, do not go to completion, and not as much product is produced as you expected. So we can express what is produced as a percentage of what we expected to get out of a particular reaction. So let's use a little sports example. A certain basketball player may take 100 shots, but only make 70 baskets. So what percentage did they make? Well, this one in this example is pretty straightforward. The amount that they actually got was 70, divided by how many times they tried, times 100, divided by 100, and all percentages are multiplied by 100. This basically works out to 70%. He got 70% of the shots that he tried to take. So the formula that we use here is percent yield is actual yield divided by theoretical yield times 100. And let's kind of define these terms. So actual yield, y'all, think about what the word actual means. It means reality, what actually happened. So the actual yield is either measured in the lab. We will do a lab later this year where we actually measure how much product we get. You will put it on the balance and see how much it is. It's how much you actually got, okay? Or if it's a word problem, if we're just asking you to do the work, it might just be stated in the problem. That is going to be divided by what is called the theoretical yield. Now remember what we just said. The theoretical yield is what we predict or calculate on paper using stoichiometry. So it is going to be calculated by you how much you should get, and that's called the theoretical yield. So here's a non-notes example. I'll love this because I love baking. A recipe claims to make 24 cupcakes. Great. I followed the recipe, but when I made the cupcakes in the end, I only had 18. Like, I'm done making cupcakes. Here they are. I only have 18. So what is my percent yield? Well, the percent yield is the actual amount of cupcakes that I made, which is 18, divided by the theoretical amount of cupcakes. Well, it should have been 24, and then times 100. Well, 18 divided by 24 times 100 is 75. So I only got 75% of the cupcakes that I predicted, okay? So there's our percent yield. What may have caused the lower amount of cupcakes? This is actually relevant to chemistry. You know, if you predict that you'll get 24 grams of something, but you only got 18, why? What might have happened? Well, in this case, there's a couple possibilities that I thought of. Maybe some burned, so maybe I had to throw them away. Maybe I ate some. Hopefully you don't eat your chemistry experiment, but you could certainly eat your baking experiment, and that's what might cause it to not be there. Maybe I dropped some on the ground and they weren't good anymore. Maybe my husband walked through the room and he stole one. Lots of possibilities that might result in a low percent yield. So in this case, I only got 75% of what I should get, and that's called percent yield. All right, so we are just going to jump right into some examples here. We're going to do some thinking and planning, and then we are going to actually work the problem. So here we go. Let's read. When 45.8 grams of K2CO3 react with excess HCl, 46.3 grams of KCl are formed. Calculate the theoretical and percent yields of KCl. All right, so what I like to do here is kind of zoom in and think about my balanced chemical equation here and think about the numbers given in the problem. So this says 45.8 grams of K2CO3 reacted. So I'm going to write that in here. 45.8 grams of this K2CO3 actually reacted. And what happened? When it says react with excess, you can ignore that for now. 46.3 grams of KCl are formed. 46.3 grams of KCl are formed. And it says calculate the theoretical and percent yields of KCl. So let's go through this thinking and planning box here and kind of figure out what is happening. So number one, how much reactant are you starting with? Because this determines how much product you should get. So I am starting with 45.8 grams of K2CO3. Next up, how much of the product did we actually get according to the problem? Well, the product was KCl and it said we got 46.3 grams. Cool. What is the actual yield? Well, the actual yield is how much you actually got. Okay, actual. So that's the 46.3 grams. And then finally, how do we find the theoretical yield? Well, we find that using stoichiometry. We use stoichiometry starting from the reactant that we're given, which is the K2CO3, and converting it to the product that we're going to compare it to. So we need to do that stoichiometry piece. All right, so here's just kind of a summary of what we wrote. And now let's actually solve this problem. And I need to add a page to show the work. All right, so here we go. I'm gonna get a good color. So we are gonna do our stoichiometry starting with our reactant. So that's 45.8 grams of K2CO3. I'm gonna go all the way to solving to grams of KCl so that I can compare. So I'm gonna bring down grams of K2CO3 and I'm gonna go to moles of K2CO3. I'm doing the molar roadmap in my head because we've been practicing that for a while. I'm going to bring down moles of K2CO3. And now I'm going to go to moles of whatever chemical I'm trying to get to, which is the KCl. And then I'm going to bring down moles of KCl. And I'm going to go to grams of KCl. All right, plugging in numbers now. I'm going to plug in my numbers in green. For mole to mole here in the middle, I use the coefficients. K2CO3 is 1, and KCl had a coefficient of 2. All right. In the other conversion factors, we have moles to grams. We use 1 mole equals the molar mass in grams. So I'm going to calculate the molar mass of my KCl up here first, where I have my green arrow. Potassium is 39.1, plus chlorine is 35.45. I have 74.55. And then K2CO3 down at the bottom, going to calculate that molar mass now. 2 potassium, so 2 times 39.1, plus 1 carbon, 12.01, plus oxygen, 3 times 16. I get 138.21. If you need to pause, feel free to make sure you're getting those molar masses. You want to make sure that you're following along with your calculator. All right, final step here would be to cross out our units. Make sure everything looks good. We got grams of KCl. And now we're going to calculate. So we're going to multiply across the top. Here we go. 45.8 times 2 times 74.55 divided by 138.2. And I get 49.4 grams. Now, I'm going to specifically label that grams of KCl theoretically produced. This is using stoichiometry. It's like a recipe. That's how much we should theoretically get. But the problem told us how much we actually got, right? How much did we actually get in the problem? 46.3. So our final step here is to calculate our percent yield. Percent yield. Its actual yield, which was 46.3 grams, divided by theoretical yield, which is what we just solved for, 49.4 grams times 100. And so let's grab your calculator. 46.3 divided by 49.4 times 100, 93.7. 93.7%. That's pretty good. The closer you are to 100, the closer you are to producing everything that you thought you would. All right, let's try another one. We're going to, again, think and plan before we solve. In the reaction of 39.2 grams of CaCO3, so 39.2 grams of CaCO3, it produced, sorry for my grammar here, it produces 10.2 grams of CaO, 10.2 grams. What is the percent yield? All right, so first up, what reactant are we starting with? We are starting with 39.2 grams of CaCO3. How much product did we actually get? According to the problem, we got 10.2 grams of CaO. So what is the actual yield? That was the 10.2 grams of CaO. How will we find the theoretical yield? We will do stoichiometry from CaCO3 all the way to CaO. All right, I'm going to put in that new page so that I can show our work here. All right, so let's do the stoichiometry. We are going to start with our reactant, y'all. The amount given is a reactant is 39.2 grams of CaCO3. Going to bring that down diagonal, grams of CaCO3. I'm going to go to moles of CaCO3. I'm going to bring that down, moles of CaCO3. I'm going to go to moles of wherever it is I'm going. I'm going to my actual yield actual yield unit. That's going to be CaO. And I'm going to take it one step further and go to grams. So moles of CaO to grams of CaO. All right, plugging in our units here in the middle, mole to mole, we use the coefficients. All the coefficients here were a 1, 1, and 1. For my other conversions, which are between moles and grams, I use 1 mole. So 1 mole, 1 mole. And then the molar mass in grams. I'm going to do my CaO up here in the top right corner first. Calcium is 40.08 plus oxygen is 16. That is going to be 56.08 grams. And CaCO3 down here is going to be 40.08 plus 12.01 plus 3 times 16 for oxygen, 100.09. All right, our final step is going to be to multiply across the top and divide by the bottom. 39.2 times 56.08 divided by 100.09. We get an answer of 21.96. I'm going to round that up to 22.0. 22.0 grams of CaO. Now I'm going to specifically say theoretically produced. Is that how much we actually got? Don't know. Well, we do, but it's theoretically how much should get produced. Our final step will be to calculate what's called the percent yield. So percent yield is actual over theoretical times 100. So the actual yield, y'all, that's what the problem told us was actually produced, 10.2 grams. Divided by what should have been produced, theoretically it was 22 grams, times 100. So let's divide 10.2 divided by 22 times 100. We get 46.4%. Now, that is the answer. I'm going to say that's a really bad percent. That means that you lost half of your product. It got lost or it didn't get made. Something bad was going on in the lab there and it just wasn't working out just right. All right, so those are our two examples of percent yield. We will do more in class. Thanks for watching.